This is the slope-intercept form graphing homework solution. Let me remind people that this is what we're doing. Slope-intercept form is also known as y equals mx plus b form informally, where m here is our slope and b here is the y-intercept. So I want to emphasize two things. If we're going to use this form, we need a y-intercept value, also known as a b value, and we need an m value, also known as a slope. So based on lecture and in the past Rise Over Run homework, that homework had you plot a y-intercept, and then it had you use the slope to obtain the next point. And that's what we're doing here. So for number 1, we have y equals 2x plus 1. And what this means is simply that the value 2, the number that's multiplied to x, that's my slope. And the number added to this expression of the 2x here is your y-intercept, meaning I'm adding a 1 there. So this here is my b value, and this number multiplied to x is my m value. So from the last homework, you had to plot 0, 1, which was a y-intercept, and then you had to use a slope of 2. And this is what we're doing to graph equations that are in slope-intercept form. You need a slope, you need a y-intercept. This is the form we use, and we're going to graph all these problems using this approach or using this technique. So now in some ways you could go back to the Rise Over Run homework, and this now just becomes the Rise Over Run homework. Plot your y-intercept because you have the x-coordinate and the y-coordinate. You start at 1 on the y-axis, that's your y-intercept value, and then you use the slope of positive 2, but we need a rise over a run. So we divide by 1 since we have a whole number. So we have a rise of 2 and a run of 1. So all the homework you did in the past, you're going to now do again in some ways, but this time they're giving you an equation in slope-intercept form. So let's try this out. 0, 1 and 2, 1. We need some graph paper. Again, we have the x-axis, you have the y-axis, and let's determine where we actually plot our first point here. So, 0, 1. The y-intercept is at positive 1, so it means I go up only 1 unit. I'm at 1 on the y-axis. Label this y-intercept. We're at 1. We're now going to use our slope to get the next point. Our slope here is 2 over 1. Up 2 to the right 1 because both of these numbers are positive. Up 2 to the right 1 from the y-intercept. 1, 2. Now to the right. This is the location of our next point. We can now draw our line. Here's how. Notice what we just did. We graphed the equation y equals 2x plus 1 using slope-intercept form. And that's what we're going to be doing for all of these problems. Number 3. y equals x plus 3. Now, we're going to use slope-intercept form. The number in front of x, we say, there's no number, but there really is. It's a positive 1. So what this means here is simply that if we use the same system, my slope here is a positive 1. My y-intercept is at positive 3. So this is what this means. The y-intercept is at positive 3. That's a b value. My slope here is positive 1. Now, I'm going to transition here because y-intercept has the address is 0, 3. So what I'm going to use now for my y-intercept is that b value because we're using slope-intercept form. So I'm not going to write this 0, 3 anymore. I'm going to use b being 3 and m being 1, and this is what we're looking for. We're going to now use this information. Don't forget that I have to have a rise over a run, and so that number 1, we divide by 1. We can now use the slope. So we're going to plot the point at 3. Let's get some paper. And I'm going to erase some of this here for us. So let's remember, well, I guess we should just go back and keep it there for the time being. Y equals mx plus b, and let's just use our paper here in the bottom. Okay. We have the x-coordinate, we have the y-coordinate. Our slope is at positive 3. So, the y-intercept. 1, 2, 3. This is the location of the y-intercept. It's at positive 3, and again, you can label this at 3 on the y-axis. We're going to use the slope of 1 over 1, up 1 to the right 1. So now we go up 1 to the right 1, and this is the location of our second point. We're now going to draw our line. This is number 3. Number 5, y equals negative x plus your 4. Now remember, the number multiplied to x is negative 1. We're using slope-intercept form. So in this case, my m value is here, and my b value is here. So my slope is negative 1 over 1, and my y-intercept is a positive 4. We're going to be a bit more efficient about how we do this. X-axis, y-axis. We're going to start by plotting the y-intercept at positive 4. So that's up 1, 2, 3, 4. This is the location at 4. We're going to use a slope of negative 1 over 1. And what that means is I go down 1 and I go to the right 1. From this y-intercept, so if you like, label here your negative 4. Now go down 1 and to the right 1. This is the location of your second point. We can now draw our line. We got 2 points here. This is L. Number 7. Y equals 1/2 x minus 1. Now, very often people say, okay, what's my y-intercept, since, I know that the m value here is the number multiplied to x. In other words, m is 1/2. The question becomes, what's your b value? Now, your b value here is -1. This is your b value. And sometimes people get a little confused, and I have to remind them and say, isn't it true that I can add a -1, and that's the same as really subtracting 1, because a subtraction is addition of a negative. So it's now easier for you to see that the b value is actually -1 when they give you 1/2 x minus 1 there. So I have a y-intercept value of -1, and I have a slope of 1/2. Let's graph. We're going to start at -1, and that's going to be down 1 unit on the y-axis. And again, you could label that. I'm now going to use a slope of 1/2. So I'm going to go up 1 and to the right 2. This is the location of my second point. We're now able to draw a line. Oops. Let's get the iPad to cooperate. This is like my line now. Number 9. Y equals -3/2 x minus 4. My slope here is -3/2, so I'm going to label that. And the y-intercept is -4. Now remember, my slope is negative, so I'm going to put that negative value on top, so that my rise is actually going down 3 and my run is going to the right 2. The y-intercept is at -4. Let's graph. You have your x-axis and you have your y-axis. You're going to start at -4. So I'm going to have to go down 4 units on the y-axis. 1, 2, 3, and 4. That leaves me at -4. I'm now going to use a slope of -3/2. So I go down 1, 2, 3 units, and to the right 2 units. This is the location of my next point. Here's my line. Number 11. Y equals x. Notice here, the slope is the number that's multiplied to x. 1. There's a 1 multiplied to x because 1 times x is x. And then you might say, okay, I understand that my slope here is 1, but what is the y-intercept? And I'm going to say the y-intercept is 0. It is 0 because I can add 0 to any number, and it's always itself. So my y-intercept is actually 0. And we're going to use this. We've seen in the last homework section, the rise over run homework, that we have an x coordinate, a y coordinate, your y-intercept is at the origin, it's at 0. Now we're going to use the slope here of 1, which is really 1 over 1. These numbers are both positive, so it means I go up 1 and to the right 1. Here's the location of my second point. This is number 11. Number 13. Y equals 3/4 x. Again, don't forget, we're going to put this in slope-intercept form, meaning my slope, m, is the number that's multiplied to x, and that's 3/4 here. We're going to add a 0. And so here, b is 0. My y-intercept starts at the origin. X-axis, y-axis. Here's my y-intercept. It's at the origin. We're now going to go up 3 units, and we're going to go to the right 4 units. 1, 2, 3, 1, 2, 3, and 4. This is the location of my next point. Let's draw our line. Here's A. Ooh. I wish I had an undo function. Sorry. Let's try that again. I had it right the first time. There we go. Here's our line. I was just trying to get rid of some of these points here, so let's be careful. Okay, number 13. Number 15. Y is negative x. And don't forget that negative sign is really negative 1 times x. So that means that our slope value, which is the number multiplied to x, is negative 1. And then we're going to say, what is the y-intercept? We can add that 0. So b here is 0. The y-intercept is at 0. X-axis, y-axis. We're going to start at the origin, which is 0. Now again, the slope here is negative 1, so this is negative 1 over 1. That means I go down 1 unit because, again, the negative direction on the y-axis is down, so I'm going to go down 1 unit and to the right 1 unit. This puts me at the location of the next point. Slope is negative 1. We now get to draw our line. This is L. Number 17. X plus 3y equals 9. Now remember, we're trying to draw this in slope-intercept form, also known as y equals mx plus b. So what you're going to have to do here now, if you notice, is you don't have y by itself. You have x plus y, or x plus 3y is 9. You're going to solve for y. You're going to solve this equation for y so that you can use the slope-intercept form. So this is kind of a classic question here. And if you did your formula homework worksheet, you notice I did a ton of these examples. So if you want to review that, that's kind of what you have to do if you don't remember what to do. So let's solve this equation for y. And we're going to do that by subtracting x from both sides. You end up with 3y is negative x plus 9. You're now going to divide both sides by positive 3. And you end up with y equals negative x over 3 plus 9 over 3. Now, remember, we're going to have to simplify both of these things. So, let's recall. The fraction here that's multiplied to x is actually negative 1/3. So what you're going to have now here is y equals, let's go down here, negative 1/3 x, and then you have this fraction here of 9/3. We're going to have to divide, and 9 divided by 3 is positive 3. We now have our slope, we have our y-intercept. Our slope is negative 1 over 3, and the y-intercept is positive 3. Don't forget that negative 1 belongs in the numerator position. So we have negative 1 divided by 3, and now we can graph. X-axis, y-axis. The y-intercept is at positive 3, so we're going to go up 1, 2, and 3. And this is the location of your y-intercept. We can label it, if you like, at negative 3. And from here, we're going to go use the slope. We're going to go down 1 and to the right 3, because our slope here is down. It's negative 1. It's to the right, positive 3. The numerator is going up or down. Since it's negative, you go down 1 unit. Point being, this is the location of your second point. We can now draw our line. Here's the graph. And that was number 17. X minus 2y equals 8. Again, we need this in slope-intercept form. We have to solve for y. X minus 2y is positive 8. Subtract x from both sides. Negative 2y is negative x plus 8. Divide both sides by negative 2. you get y equals negative x divided by negative 2 plus 8 divided by negative 2. Remember, there's a number in front of that x, which is negative 1. So when we simplify our fractions, let's notice what we have. Negative 1/2 divided by, or I should say negative 1 divided by negative 2. What that gives us is positive 1/2 times that x. We now have over here a positive 8 divided by a negative 2, and that's going to give us a negative 4. This is what we're going to use. We have our slope to be the number multiplied to x, which is 1/2, and the y-intercept to be what you have here, the number added to it, which is a negative 4. So we're going to use a slope of 1/2 and a y-intercept of negative 4. Let's get out our graph paper. We have the x-axis. We have the y-axis. Now let's see where the first thing we have to do is we're going to have to plot the y-intercept of negative 4. So we're down 4 units. 1, 2, 3, and 4. This is the location of my first point. I can label it. I start at the y-intercept of negative 4. I use the slope. The slope is 1/2. That means I have to go up 1 unit and to the right 2 units. This is my second point. Let's draw our line. There you go. This is what we're looking for. Number 21. 2x plus 3y is 12. This is not in slope-intercept form. As you can guess, we need to solve for y. Subtract 2x from both sides. You obtain 3y is negative 2x plus 12. We're now going to divide both sides by 3. We have y equals negative 2x divided by 3 plus 12 divided by 3. Y will be negative 2/3 x plus 4, because if we focus on the fraction, negative 2 divided by 3 is negative 2/3. 12 divided by 3 is 4. We now have a slope of negative 2/3 and a y-intercept of positive 4. Let's use our information. X-axis, y-axis. The y-intercept is going to be at positive 4. So I'm going to go up 4 units. 1, 2, 3, and 4 on the y-axis. I could label my location. I'm now going to use a slope of negative 2/3. So let's be careful here again. Okay, because the slope is negative, I'm going to put the negative sign on top. Then I'm going to divide by 3. So that means I go down 2 units and I go to the right 3 units. So let's try that. 1, 2, 1, 2, and 3. This is the location of my second point. Here's your line now. (23) 6x minus 4y is positive 20. You're going to have to solve for y. Subtract your 6x from both sides. Negative 4y is negative 6x plus your 20. We're now going to divide both sides by negative 4. Y is negative 6x over negative 4 plus 20 over negative 4. So here's what we're going to focus on now. Negative 6x over negative 4. So let's notice that negative divided by a negative is a positive. So this number is going to be positive 64x plus, if we look at this as positive divided by a negative, giving us a negative 5, we can do that. 20 divided by negative 4 is negative 5. I'm now going to simplify the fraction 6/4. 6/4 is written as 3 times 2 over 2 times 2. And we get 3 halves. Here's what we get. Y is 3 halves x minus 5. Our slope here is 3 halves, and the y-intercept is negative 5. X-axis, y-axis. Negative 5 is a y-intercept value. So you're going to go down 1, 2, 3, 4, 5 units. This is where negative 5 is. We have a slope of positive 3 halves. So we're going to go up now. 1. Let's go up. 1, 2, 3. Let's double check. Yep. Up 3 to the right, 2. This is the location of our second point. Draw a line through these 2 points. And you're done. Number 25. For x minus y is negative 3. We have to solve for y. Subtract your 4x from both sides. Negative y minus 4x minus 3. Now remember, there's a negative 1 multiplied to y. Right? So we're going to divide both sides by negative 1 to get cancellation. You get y is negative 4x divided by negative 1. Let's say plus a negative 3 divided by a negative 1. I could write subtraction as addition of a negative. Now, let's focus on the fractions here. Negative 4 divided by negative 1 is positive 4. And then I have a negative 3 divided by a negative 1. That gives me positive 3. So this is 4x plus 3. That means our slope is 4, and our y-intercept is 3. Here's my m value, here's my b value. Now remember, if a slope is a whole number, divide by 1, so we now have a run. Let's graph. X, y. Y-intercept of positive 3. Go up 1, 2, 3 units. This is the location of my y-intercept. I'm now going to use the slope for 1. So I go up 4 units. 1, 2, 3, 4, and I go to the right 1. This is the location of my second point. We're going to draw our line. And we're done. Number 27. Let's double check we're not doing it twice. Yep. 3x minus y is negative 6. You have to solve for y. Subtract 3x from both sides. Negative y is negative 3x minus 6. Don't forget, you have this negative 1 there. So you can divide both sides by negative 1. Y is negative 3x divided by negative 1. And I'll write this as plus a negative because subtraction can be written as addition of a negative. Let's focus on the fractions. You now have negative 3 divided by negative 1. So we got y is positive 3x, and then I have a negative 6 divided by negative 1, which is plus 6. So if we look at our equation, we find our slope to be 3. We find our slope to be 3 and our y-intercept to be positive 6. And again, this is 3 over 1. Let's get a graph paper. X-axis, y-axis. The y-intercept is at positive 6. 1, 2, 3, 4, 5, and 6. This is the location. Here's my 6. I'm going to now use the slope of 3 over 1. So I'm going to go up 1, 2, 3, and to the right 1. We're going to draw a line. Here you go. This is the line, and we're done. That was number 27. Let's look at 29. Negative 3x minus y is positive 4. We have to solve for y. We're going to add 3x to both sides. We get negative y is 3x plus 4. Divide by negative 1 for both sides. I get cancellation. Y is 3x divided by negative 4. Or I should say, y is 3x divided by negative 1 plus 4 divided by negative 1. And now let's focus on the fractions here. 3 divided by negative 1 gives us negative 3. And then we have a 4 divided by negative 1. And that gives us simply negative 4. Our slope here is negative 3. The y-intercept is negative 4. We have an integer for a slope, so we're going to divide by positive 1. Let's see what the graph looks like. X-axis, y-axis. We're going to start by plotting the y-intercept at negative 4. 1, 2, 3, and 4. This is the location of my y-intercept. Our slope is negative 3 over 1. So that means I go down 1, 2, 3 units. Then I go to the right 1 unit. This is the location of my next point. We're going to draw a line. And we're done. Number 31. Negative 2x minus y is 2. We're going to solve for y. We're going to add 2x to both sides. You get negative y is 2x plus my 2. You're going to divide both sides now by negative 1. Get y equals 2x divided by negative 1 plus 2 divided by negative 1. You're going to focus on your arithmetic here, your division. You get y equals negative 2x, positive 2 divided by negative 1 is negative 2. Our slope here is negative 2. The y-intercept is negative 2. So we get negative 2 over 1 for the slope. Let's get our graph paper. x-axis, y-axis. I'm going to start with the y-intercept at -2. That's down 2 units on the y-axis. This is my location. If you like, label this at -2. Here's what you're going to use. You're going to use the slope of -2 over 1. That means I go down 2 units and I go to the right 1 unit to determine the next point. I'm using my slope of -2 over 1. We're going to draw our line. And we're done. Number 33. X is 3. Now, you might say, well, aren't we supposed to write this in y equals mx plus b form, slope-intercept form? And I'll say to you, well, yes, but these are some special cases. What you're looking at here is either going to be a horizontal line or a vertical line. Now, let me look at the graph here and demonstrate something to you before I explain the details of this. Let's get out a graph. And there's a couple of ways you could do this. We talked about this in class. Remember, x is 3 is going to be, there's more information. You need the y-coordinate value. And remember here, if you have x is 3, x is constantly 3. That means y is arbitrary. It means y, if we spell arbitrary, arbitrary, any value of y will work. That means y varies. Y could be any real number. But x is constantly 3. So what that means is go to the x-axis here at 3. 1, 2, and 3. I can have any value of y. So long as x is 3. So I'm going to plot a couple of points here to illustrate my point. If y is 0 and x is 3, I'm right here. Right? If x is 3 and y is positive 2, I go to the right 3 and I go up 2. If x is 3, let's look at these points, and y is negative 2, I go down 2 units. The point I'm making is, if you ever have x equals a value, a number, you're always going through that x-coordinate value. So what you really obtain here is a vertical line. And some people just simply memorize it that way. They say, if x is 3, I just simply go through the x-coordinate value of 3 right here. We're going to label it. And I simply draw my vertical line. So when x is 3, we always get, or let's say when x is constant, x is a number, we always get a vertical line going up or down. And this is what some people actually remember. Simply a vertical what? Line. When x is a constant value. $35. 35 is similar. X is -5. What that means is we have a vertical line through the value x is -5. So we have an x coordinate, we have a y coordinate. Draw a line through -5 on the x-axis. 1, 2, 3, 4, 5. Here's my location. X is -5. Let's draw a line. And you're done. This is the line that's vertical that goes to the x-coordinate of -5. Similarly, 37, we have y is 4. Same reasons. X varies, but y always has to be 4. So we're going to go through again the y-coordinate value of 4 for any value of x. And notice what you get. Y is 4. 1, 2, 3, and 4. Now x could be any number again. So I can plot 2, 4. So I go to the right 2, up 4. Here's 2, 4. I can plot -3, 4. So I go to the left 3 units. 1, 2, 3. And then I go up 4 units. Notice again, we get a line. And this time we're going through the y-coordinate value 4, or the y-intercept of 4. If we draw a line, notice what it becomes. It's a strictly horizontal line. And that's what you get when y is constant. It's a horizontal line. Y is constant. So some people just remember that and they go through whatever the constant value is for their horizontal line. It's number 37. Number 39. Y is -6. We know this is a horizontal line. Let's add the graph paper. You got the x-coordinate, you got a y-coordinate, all through -6. There you go. Draw your horizontal line. And you're done.